Hello everyone. Today we are going to discuss some of the basic C++ tricks um, which any of the beginners must know. So let us start. We will start with writing a fresh program in C++ and thereby we will see one by one each of the simple tricks or the concepts in the C++. So let us start. One thing to remember here is that why we write int main, because int main in C++ by default returns 0, and we need not to write explicit return 0 here. It is introduced by the compiler by itself, but let's write it for the safety. Also, other than any uh, non-zero return, if we will be returning here, what will happen is it will be interpreted as something else. So it is always better to return 0. Okay. Also, please do remember that void main is will give you error during compilation, because void main is kind of banned in C and C++. So always we need to return int main, the first thing. And okay, so the first thing we will see about the macros. There are some of the macros in the C++ which you should use. For example, there is one very good macro called um, int max. Okay, and there is something called int min. So what they do is they are containing or they are storing the constant value of the minimum or maximum value an integer variable can store. So if I do just so what I'm doing is I'm simply printing out the integer max and integer min value with separated with a tab space. So we can see here, this is the integer maximum value and this is integer minimum value. And if I'll just observe, if you'll just observe here that this is the value which we have received. So you see from here, we can um, see that this integer is taking 4 bytes of space. Why I'm saying that? Because the maximum value an integer variable can store is this. So if I'll do 2 to the power 32, okay, so this will give me the maximum value of an unsigned integer. Okay, so this is giving me something like 4 billion, 4.29 billion or something. If I divide it by 2, so this will give me the signed limit. So if you'll notice here, this is same as this. Okay, so this is the limit of integer maximum and minimum. So they are taking 4 bytes of space. Okay, so because this int underscore max in the capitals is specifically allocated for storing this values, so you cannot obviously declare any variables with this name. Now the second point here is we should use sometimes typedef. What is typedef? It basically it's a kind of alias, you can say, where we can give a different user-friendly name to some long data types or some long class types. So for example, if I write long as LL, so what it does is next time I will not have to write long I. For example, if I'll have to print long my value. Okay, so instead of this, I can write simple long my value 1, something like this, and then I can go forward from here. So typedef is used basically to give a short name to some long variable, long data types or class types or structure types, anything you can say. Okay. So not only to this primitive data types, we can also give typedef to something like this, vector int vi. So what it will do is, it is giving a short name vi to the vector int. Okay. Now let's come to the another small point for odd and even number determination. So in a normal simple way, what we do is, normally for determining if a number is even or odd, what we generally do is, for example, if I have number 1, 2, 3, 4, 5, okay, what I do is I perform modulo operation with 2, and thereby I simply conclude that if this modulo operation evaluates to 1, that is remainder is 1, then I conclude that this will be an odd. Okay, else I'll simply mention it as even. But you know what is the problem here? For example, this is an odd number, so if I'll just run it, what will happen is, I think just after this it will print odd. So you see this number is odd. So what is problem here is, let me just write here, I can write here either and l or slash n. Okay, anything is fine. So yeah, so the problem here is, in order to determine whether this is odd or even, the whole number has to be kind of divided by 2, and then we will come to know that what is the remainder. So an improvement could be, why we are dividing the whole number when we are just interested in knowing the last digit number or the least significant number. So what we can do here is, um, we will use the shift operator. Sorry, not shift operator. I think we can use the bit operator. Yes. So in the bit operator, if I'm interested in knowing that what is the last digit or the least significant digit in the binary representation of this number, and if it is 1 or not, so I'm basically doing AND operation with the last significant number. Okay, so if this evaluates to 1, then this is an odd number. Otherwise, if this, let us say this number is 5, okay, so 5 in binary is represented as, let us imagine that it is 1 byte representation. So this is 5. And if I'll do AND operation of this number with 1, this, then what will happen is it will evaluate to 1, right? Because it is only having the least significant digit 1 here. So everything else will be 0. Only this 1 will be left. Okay. So if this is evaluating to 1, then it will be printing odd. So you can see that it determined it correctly odd. If let us say I print 6, this will determine as even. So definitely this is an improvement over the whole number division. Okay. Next, let us look at how we can determine what is the data type or the type of an variable. Okay. So in C++, there is no direct way, just like in Python we have class, in Java we has a type of, and in JavaScript also we have something called type of function, internal functions to determine the data type. But in C++, it's not that much straightforward. So for determining the data type, for example, if let us say I have one variable int I is equal to 10. Similarly, if I have one float is equal to, let us say, the pi value. Okay, and if I want to know that what is the data type of I, so what I need to do is I need another header for this. The name is type info. Okay, and using the type info, I will do cout, let us say, and l. Okay, and type id is a function, and inside that I'll write I because I want to determine the type of I. Okay, like this. So this will determine for I. In the similar way, if I want to determine for f, then I'll just write here f. Okay, so let me run it again. Also, let us say that if I have, so you can see that data type of I is I. So I denotes basically integer. F denotes float. For example, let us say if I have one simple class, let me write one empty class. Okay, so this is just an empty class. And if I write the same thing for this, so here I need to mention here my class name is my class. Okay, so I'll just write here C. So what it will do is it will determine the type of this variable C as my class. My class. You see, my class. So this is the way to determine the type of variable, data type of variable. Okay. Again, another point I want to talk here is, let us say if I have one variable int I. Okay, let me just comment out everything so that it will be easier. Okay, let us say that if I have int I is equal to, let us say, 10, and if I'll do just cout I, it will give me the value of I. But at the same time, if I'll just do with the ampersand operator, so always remember ampersand. Okay, ampersand operator is for getting the address of. Okay, so it will give me address of I. In the same way, I have another operator called asterisk. Okay, so this will give me the value at I. Okay, so here directly I can't use asterisk I because value at operator expects one address. So here I can mention it something like address. Okay, so basically here I represents the variable name, ampersand I represents, ampersand is equal to basically address of. So whatever I'll write inside the, after the ampersand, so it will print the address of that variable. And asterisk, asterisk basically represents value at. So value at particular address. So obviously the parameter it will take, or the the variable it will act on should be address of something. So value at that address. Okay, so this is how it works. So here this will print 10. This will print the address of I where 10 is stored, and this will print value at the address of I. So obviously again 10. So let us run it. So you see, the first one printed 10, then this is the address where I is stored, or sorry, 10 is stored. And this is again the value. at the address of I. So 10. Please notice here, this is a hexadecimal address. Why? Because it is starting with 0x. Okay, anything starting with 0x represents hexadecimal number. So here you can notice that the address is hexadecimal and it is 6-digit hexadecimal number. So if each digit represents 1 byte, each digit represents 1 byte, then this 6-digit, okay, each digit can represent 1 byte. So each digit can have 16 types of value from 0 to F. Oh, sorry, 0 to E. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. Yeah, so 0 to F, yes. So each digit can represent 16 values, and we have how many digits? 6. So here it means that each block of memory can represent this much byte, or we can say that if we divide it by 1024, so this many kilobyte, or if we'll divide it by 1024 further, it means this many megabyte. So each memory unit in my RAM represents or consists of 16 megabytes of memory. Okay, so this is important to understand that how the memory blocks work in the RAM. And also, please notice that whenever our program runs, that program is first brought to the, or the executable is first brought to the RAM and then it is executed. Okay, let's move forward. Okay, so next now we will see that how we can determine the size of the array. Please remember that in the C++, there is no direct way to determine the size of the array. Okay, so how we determine the size? So let us say if we have an array of length 3, okay, how we will determine its size? So one way is there is an operator called size of. Okay, what this size of does is it tells us the memory size of the variable. Okay, so as you all must be knowing that if I write ARR here, so ARR represents the whole array or the address of the, or the base address of the array. So it means that the first element's address of that array. So size of ARR means that size of the whole array. It will give the size of the whole array in the bytes. Okay, and if I'll write simply here size of the first element, something like this. So what it will give me? It will give me the size of the array, which is 3. Okay, so let me run it. So you can see that the size is 3. But let us say if I'll give only this much, then what is the size? Then it will give, because this is an int and each of the int is 4 byte, so it will give something like 12. 3 size into 4 byte each, so 12. Okay, now what I'll do is instead of array first element or the int, I can directly write here int or the data type of the variable which it is storing. Okay, so here if I'll write int and then if I'll run, what will happen is it will again print 3. Okay, so this, let me clear it again. So now there is one more way we can write here, or we can determine the size of the whole array is something like this. If I'll write star value at address of ARR plus 1 minus ARR. So you must be thinking that what is this representing? So here, basically, this represents the base address of the array, and this also represents exactly the same, that address of the base array, okay, or the address of the first element. So here the value at this total array minus array will give you the 3 again. So let me run it again, and it will give the 3 here. So you see, we can see here that 3 is given. So now in this small video, we have learned some of the basics or tricks in the C++ for the beginners. Please comment how you felt about it. Did you learn anything new? And I'll post the next part again. Thank you.